I have the pleasure of introducing Kristin Conrad. Kristin. I don't know why you look embarrassed every time I say your name. Uh, anyway, so Kristin Conrad's a research and extension associate on the forestry and natural resources team here at K-State. She specializes in native bee ecology, right? We think that's pretty unique, and we love having Kristin on board, right? Prior to working at K-State, she spent time at NC State working on projects related to native bee health, rare plant pollination, and plant pollinator phenology. At that time, she was working with other native bee experts, creating taxonomic guides for parasitic bee groups. And I'm going to keep mentioning that Kristin is also going to be working for us on things like native bee habitat guides and stuff like that. So across our different types of natural areas. And she earned at that time her professional environmental educator's certification through AmeriCorps, service with KEEC and EKU. She spent a season with the USDA working group on crop breeding, so she got to be the bee, right? Okay, that wasn't my joke. I'm reading, I promise. But it was good. Yeah, she wanted me to read that. Yeah, so Kristin earned her master's in biology at EKU. Who's from EKU or a EKU alum? We always have a good showing from EKU, right? We've stolen people from EKU, so we have good folks here too. Yeah, and she got her bachelor's. So with her master's, she worked on plant pollinator interactions and crop pollination in tropical mountains. And I was fortunate to get to go to some tropical areas with Kristin and have her run around like crazy, like just point out every bee. It was good. I'm messing with her positively. And she got her bachelor's in biology right here at K-State. And with that, Kristin's going to tell us a little bit about a pollinator habitat project she's got going on.
All right. Just make sure I am oriented here. Okay, there we go. All right, first off, I want to thank you guys again for coming. This is always a big part of our year, and we're always so excited to do it in December. So thank you all for coming. I'm going to talk about the relative efficacies of several pollinator habitat establishment systems. So this project was born out of just the simple question of what is the best way of establishing pollinator habitat? I was recently presenting on this project at the KAEE conference, and someone ran up and was like, help, I've spent 2 years on this. I did 2 rounds of spraying. I planted these seeds from roundstone. I'm seeing a mix of like foxtail and Johnson grass, but I'm seeing, black-eyed Susans and everything too. And I was like, fear not. This is a long process, and honestly, you're seeing exactly what we're seeing. So you have not failed yet. It is a long process, and getting to see that succession happen over time has been a really big highlight of my year, honestly. So all right, so why do we establish pollinator habitat? Like, why do we even care? Native bees are responsible for pollinating approximately 80% of the flowering plants around the world. And the reason we focus on bees, or the reason we talk about bees primarily when we talk about pollination, is because bees are the most efficient of all the pollinators. This is due to the fact that while most other pollinators are visiting flowers to collect nectar for consumption, they're really collecting pollen and moving pollen by accident. Whereas bees, on the other hand, they'll visit flowers to collect nectar for their own personal consumption, but also pollen to feed their brood with. There are about 3,500 estimate species of native bees in the US, and there are about 400 estimated to occur in Kentucky. And then this large diversity really requires a diverse habitat, of course, in order to provide resources and specific pollen sources, because there are a lot of specialist bees mixed in there as well. However, 50 to 75% of the land in Kentucky is utilized for agricultural use, and that means that quality bee habitat is largely fragmented and really hard to find, especially for your smaller, small carpenter bees, sweat bees, things like that might not have the flight range of a honeybee or a bumblebee. So native pollinator habitat, it serves a lot of different purposes, but the ones I want to highlight is it can serve as a corridor and reduce that habitat fragmentation. It can catalyze that flora and fauna diversification in an area. It can serve to control erosion in an area and provide some sort of root structure. And then it can supplement your agricultural production goals too. Depending on what you're growing, you might want more bees around. So within pollinator habitat, generally you can break it into 3 components: your plants, your nesting habitat, and your management or your maintenance of that habitat. So with plants, of course, we want native plants, and ideally locally sourced seeds are best, but broadly native is still much better than, invasive. We want them to be appropriate, and what I mean by that is like appropriate for your ecoregion and for your soil conditions, and then diverse. And not only diverse in species, but you want them to be diverse in their blooming periods, their color, their shape, because that's going to attract your diversity of native bees. Next, we have nesting habitat. This is something that generally you don't have to do a lot of work to have. But ideally you want, bare soil or mud, something exposed, but not compacted, because 70% of your native bee species actually nest in the ground, and their nests are incredibly difficult to find. Typically, there's not a whole lot happening above the surface, and you'll just find like this little hole about the size of like a pencil eraser, and that's the entrance to the nest. Now, there are a lot that do have something going on above the surface, like a turret or something of some sort, and you're able to see like, oh, that's a turret. It's probably a mining bee in the Andrena group or something like that. But for the most part, you're going to have a hard time figuring out what it is. You want hollow stems, so there are, the other 30% of bees are cavity nesters, and there's a decent percentage of those that, we're all very familiar with large carpenter bees, but small carpenter bees are their itty-bitty tiny little cousin, and they've got these weak little mandibles that can't chew through hardwood. Like they have to have exposed, like soft pith to chew through, or a cavity that already exists. And then the management or the maintenance of this, and that's, of course, the most important part. So obviously you want to, we hear a lot of this about leave your leaves, leave your dead stalk. Sometimes the hardest thing to do is to just simply leave it, but pesticide use, we're talking, we just had our Iroquois project spoken about here, and, we use a lot of pesticide. So you want to, obviously just be conscious of what you're doing, what you're using. Are you using an appropriate pesticide? Are you going to have to spray a lot? Are you worried about insects? Or are you, make sure you're using the right thing and you're using it in a very responsible, targeted manner. And then also, if you're thinking of insecticides, maybe reassess the pest activity you might have going on and think like, is this, this is a natural area we're rehabilitating. You expect and accept a little bit of pest activity. And then last, of course, is the invasive species management, the hardest part, and naturally the most important part of this. So these are images from before we started doing any site prep in our pollinator habitat area, and then directly after doing the site prep. So you can see we went from, vegetation to bare ground in these images. Site preparation for establishing pollinator habitat typically takes 1 to 2 years. And that's why I told, the woman I was speaking at the KE conference, I'm like, you are just in the beginning. Don't get discouraged yet. You're heading there. The most common methods typically involve herbicide use and tilling, of course, to some degree. However, a lot of these methods, the ecological effects of these are poorly understood. We see a lot of like, how does it persist in the environment and things like that more immediate within like that first year. But after, the first 2, 3, 4, 5 years, we don't really truly know what that effect is. And then site implementation is typically, unfortunately, performed inadequately often, and that, results in poor invasive species management and therefore poor native seed establishment. All right, so our goal with this project was really just to answer that simple question of like, we've got this hay field. What is the best way to establish pollinator habitat in that? So, and then also, use that and then provide a more accurate guidance for people who are wanting to establish pollinator habitat. So this project actually takes place here on the farm. It's just over the hill. If anyone is interested in going to look at it, it doesn't look very exciting right now, but I'll happily take you down there and show it to you. It takes up about 2.5 acres, and we did like a randomized block design. So there's 4 blocks, and within those blocks, there's 6 treatment types. So there's 4 replicates of each treatment. And then here is just another view of the plot layout. So I mentioned, so in essence, I mean, we kind of looked at like 5 different methods and then a control or a kind of do nothing method, just throw seed out and see what happens. 4 of our methods included conventional herbicide, and 1 method we used an organic herbicide. So the conventionally treated plots were treated with a 2% glyphosate plus 1% 2,4-D, and the organic treated plots were treated with 8% pelargonic acid. I'm going to go ahead and reiterate, I am a native bee person, so herbicide is new to me. If you have questions more specifically about these things, might be best to go find Jody. So here you can see our control plots are in green. The conventionally sprayed plots are in red, and the yellow plots are organic plots. So in our first treatment type, we did 2 sprays in the spring and the summer. In our second one, we did 3 sprays across spring to midsummer. And this all took place in 2023, with some of it happening a little bit earlier, like anything that had to take place in the fall or winter prior to those sprays happened in 2022. Our third treatment type, we did 4 sprays, so 1 in the fall of 2022, and then 3 from spring to midsummer in 2023, and then in between that, after that fall spray, we used a fall cover crop. And then in our last conventionally treated plot, we did a conventional winter till, followed by a cover crop, and then that next year we did 3 sprays from the spring to the midsummer. And then in our 5th treatment type, we used our organic herbicide. So we did the same thing as our 4th one. We did a till, a fall cover crop, and then 3 organic sprays from the spring to the midsummer. And then our control plots or our do nothing plots. So to assess the change in the plant community over time, we performed a vegetation survey within each of these plots. So we collected species and percent cover using a 1/2 meter quadrat before any site prep happened in September of 2022, and then after all of our treatments in October 2023. Our seed installation was, or our seed mix was planted by Roundstone using a no-till seed drill, and that happened in September 2023. So nothing, had sprouted by October 2023, getting tangled in my 2020s. Nothing had sprouted by October 2023, so, naturally we saw a lot of dead vegetation. And then in our first year survey, we went out in May, July, and September throughout the growing season this past year and did that same survey. And these are some of the, I wouldn't call this statistical analysis, but some preliminary results, I guess I could say. So I grouped all of the plants into 6 different categories so that we could have an easier time of, just looking at that and really understanding how each of these treatments are affecting these different plant groups. So the first, we wanted to look at dead vegetation and bare ground, because naturally, we want some dead vegetation and bare ground so our seed mix can establish. Pre-treatment to post-treatment, there was a large increase in that dead veg to bare ground in the conventional and organic. In the conventional, and then the organic more closely resembled our control plot. Post-treatment to now, we're seeing a lot of regrowth in the conventional plots, and then pre-treatment to now, so overall, all experimental plots really resemble each other in this category. Here we're looking at non-native perennial grasses that were in the plots, so our Johnson grass, our Kentucky bluegrass, orchard grass, and tall fescue were included in this category. Pre-treatment to post-treatment, there was a large increase in the dead vegetation and bare ground in the conventional, and then the organic, again, more closely resembled the control plot. Post-treatment to now, we're seeing a lot of regrowth in the conventional plots. And then pre-treatment to now, overall, again, all the experimental plots really resemble each other. All the conventional plots really resemble each other there. And I skipped one, my bad. All right, so our non-native annual grasses included crabgrass, foxtail, and brome grass. Pre-treatment to post-treatment, there was a large increase in treatment type 3. So that was our 4 sprays, our no-till, and it got a fall cover crop. Post-treatment to now, the results are honestly pretty all over the place. Like there wasn't really any clear trend that I could pull out. And then pre-treatment to now, the conventional plots, again, really resemble each other. And except for that T2, which received 3 sprays, more closely resembles the organic and the control plots. All right, next, we had our weedy forbs. That includes things like ragweed, horseweed, and bull thistle, and several other things. But pre-treatment to post-treatment, there was the largest reduction in treatment type 3. So again, that was the 4 conventional sprays with the fall cover crop, and the type 5, so the organic. Post-treatment to now, the conventional plots performed similarly. So, and then the organic, of course, perform very similar to the control plot. And then pre-treatment to now, all the treated plots are really performing about the same. And then everything else got grouped into the other plant species category. So that's things like chickweed, ragweed, tick trefoil, plantain, things like that. Pre-treatment to post-treatment, again, everything performed about the same. Honestly, across the board, everything performed about the same in this category. And then our seed mix. So naturally, all we have is post-treatments now because it wasn't installed until after the treatment. So it was a short grass wildflower meadow seed mix from Roundstone, and includes a lot of different plants like black-eyed Susan, partridge pea. There's several mountain mints in there. There's a few coreopsis in there. Lemon mint or lemon balm or bee balm. It's called as several different things, but the Monarda one. So post-treatments now, we're seeing that the conventional plots have a higher percentage of the seed mix established, which is to be expected. With our treatment 4, so this is the one where we did everything, the winter till, the fall cover crop, and 3 sprays with a conventional herbicide, is performing the best so far, and then our organic plot is barely performing better than the control plots. So this is just to summarize those results. I don't really know what to... It's pretty all over the place, to be honest. We're seeing the best seed mix establishment in the conventional plot where we did everything. We're seeing the best control of the other plant species in that same plot. But we're seeing better management of those non-native perennials and annuals, and right now in the 3 sprayed conventional plot. Let's see. All right, so these results show the overall change in the community from the beginning of the project, so pre-treatment to now. The larger the number, the more the plant community has changed, and then the smaller the number, the less change that's occurred. So surprisingly, again, we're seeing a lot more shift to where we want to be in those plots that received a little bit less treatment, the 2 spray and 3 spray conventional plots. Let's see. So although type 4 was showing the largest change last year, for anyone who may have been here last year, I might have mentioned that in my presentation, which was expected. We expected to see the most amount of change in the plot where we did the most amount of work. We're actually seeing it right now. And again, this is just a snapshot into, a several year succession. But what we're seeing right now is the plot where we did the least amount of work is exhibiting the most amount of change. And then this is kind of just some, just to demonstrate the process along the way. This image was taken after the initial 2 sprays on June 15th. So everything that was getting sprayed had gotten 2 sprays by that point. So just to demonstrate the difference between the plots, I pulled out 1 block. So that green means there's more green in the plot, and then the more pink it is, the less plant matter was still in the plot. This image was taken by our state specialist in ag tech, Jeremy Sandifer. But I think it's pretty interesting to be able to see, even though we had only done 2 rounds of treatment at that, or 2 rounds of spraying at that point, there's such a dramatic difference. And then this image, also taken by Jeremy Sandifer, was taken in September 2023. So just a few months later, after all the sprays and treatments were implemented, and it's really wild that you can see, from that imagery, how the plots are delineated, that there's that drastic of a difference between an organic spray and the way it manages versus the conventional. And you can even pick out, like, if you know where those plots are, you're like, oh, I can tell that, like, the T2 is here because it's only gotten 3 sprays versus, plots that we've tilled in. And then these are pictures we took just standing in the plots back in September for anyone who was here on for the Pollinator Habitat Workshop Day. These were taken that day. So you can see in the control plot, there's a lot of Johnson grass that stands out right there. And then in the conventional plots, we saw, a lot of yellow popped up this year. So in our first year, a lot of the seed mix that we saw was partridge pea, plains, and lance-leaved coreopsis. We saw a lot of the lemon mint this year. So there's a lot of like the aster or the mountain mints and things like that we have not seen at all. So again, coming back to that, it's not over yet. We're on our way there. So it's to be expected that you won't see your entire seed mix bloom in your first year, and that's totally fine. And then you can see the organic over on the other side of the conventional. It kind of looks like a little bit of a mix of the conventional and the control, but it definitely skews more towards control. There's definitely a lot more Johnson grass that you can pull out of that picture than in the conventional plots. And then whoever took this picture, I am very thankful to you. This is like our best performing plot to our worst performing plot. And just that they're right beside each other and we were able to have this image is really awesome. But yeah, you can see side by side, even though there's almost no separation between the plots, that there's such a drastic difference here. So thus far, what we're gathering is that successful competition control in establishing the seed mix appears to rely pretty heavily on the conventional herbicide. It isn't currently clear how effective each additional herbicide application might be on competition control, especially considering that this takes 3 to 5 years to really establish and be able to call, it's good, it's okay, we don't need to keep going in and cutting off Johnson grass seed heads anymore. So, take it, as it is just a snapshot in time of what is going on with this project right now. Again, like I mentioned, at this time last year, the plots that received a till, a fall cover crop, and 3 conventional sprays were overall are outperforming our other treatment types. And, of course, that is expected to change and shift over the next few years as we're surveying. So the largest difference we've seen so far is in the non-native perennial grasses, where the conventional herbicide is shown to be far more effective than the organic herbicide, although we've not seen much of a difference so far in the number of applications and what effect that might have on it. So in the future, we are going to continue tracking the seed mix establishment within each plot type through 2020, summer of 2026, I believe, will be our last year that we're collecting in these plots. So we're going to be able to see it out and, see how that really ends up. We are also collecting native bees in these plots and hoping to add a small mammal component to this project as well. So we're going to be able to see just if there is a difference between the way that native bees utilize these plots and just how much of a difference there is. And I can say, we're processing bees from this year right now. Just being out and collecting in the plots this year, you could see it when you were in the plots. Like I would go from an organic plot and catching like maybe 3 honeybees to a conventional plot where I've caught like 3 bumblebees and 5 sweat bees and a mason bee and a squash bee. And so even though they are right beside each other, and I'll admit, like when I first started this job, this project was already like the site establishment or the site prep methods were pretty much already done. I somehow got lucky and didn't have to do all the hard work. Like just being out there, I can see these differences and it's wild. Like when I first started in May collecting bees, there was a lot of the black medic still in bloom and I was catching a lot of honeybees regardless of the plot type. And then as things started blooming, that shifted very drastically. The black medic died out. We started having some coreopsis and I almost quit seeing honeybees altogether, even though there are hives literally right next to the pollinator plots. So that was a really, really interesting thing to see. Something else I noticed when I was out there, I did catch some parasitic bees in the plots this year. And the ones that I caught those in were only the conventional plots. And it said that the presence of parasitic bees can be an indicator of relatively better quality habitat, because if you've got enough bees to attract, like regular bees, to attract the parasitic bees, that it must mean it's decent habitat. We are also working with soils team, specifically Jacob Brown, if he is here anywhere, to assess differences in the soil condition pre and post treatment. So hopefully we'll be able to add that into our results by next year's Habitat Symposium. And then we are also working with the organic team at K-State to develop a project very similar to this, hopefully so similar we're able to compare those results as well, but that focuses just on organic pollinator habitat establishment methods. All right, thank you all for coming again. Yeah, there's my contact information if anyone needs it, and does anyone have any questions?
Thank you. I've been in some situations where sometimes we'll be setting up or an established native area, and then somebody comes through and mows it down around May, June. And at first I'm really discouraged by that, but sometimes I see that's actually a positive. Would you all be able to go back to these plots and mow them down at a certain height, a certain time of the year, and just see if that has anything to do with the change or management?
We have kind of toyed with the idea of adding that in as a component to our project, but then decided, if we're going to run actual stats on this, that might be too many variables to add into and too much to keep track of. But it would be really awesome, and I don't see why not, like once we finish this project, to go in and mow it and then just start a new project on it where we survey how that might have affected it. But yeah, that is actually a very common practice that I had that same reaction at first of like, what? You're going to mow down everything I just worked so hard to grow? But it ends up being able to, it allows a little bit more sunlight to the ground, a little bit more of your seed mix has a chance. So yeah.
I've seen some success with that, so I'm glad that you asked about. We've bush hogged before tracks and seen some success there. My name is Julia, and I'm the director of a small nonprofit in Springfield that focuses on sustainability. I don't do as much of this work actively, but we do work with farm and landowners. So I'm going to phrase this as best I can, but I'm really interested in soil quality, and I know you haven't gotten that far yet in the testing, but specifically looking at tilling, like it was kind of looking like your plot that you did the tilling and the cover crop and the conventional sprays was kind of ahead, but then your two conventional sprays kind of snuck in there. So I'm just curious if you have any kind of like post-experiment reflections on like how tilling like came into play there, and how that might kind of play into stirring up some of those non-native seeds specifically.
Yeah, I think initially it opened up those T4 plots, the ones that we did everything in, and allowed a little bit more seed mix activity to happen there, a little bit more establishment. But because that opened up, that also opened up the seed banks for the Johnson grass to move back in. Can you tell I'm scarred by Johnson grass? So I think in essence that might be what we're seeing there, because last year it was very soon after we finished everything, and we were seeing that, and it's like, well, yeah, because we just cleared everything off of it. And now we're seeing, the seed bank that was there is probably coming back, and, but this plots that got like 2 sprays or 3 sprays without that till, it didn't allow as much of that kind of activity to happen.
Can you hear me? Okay, yes. There it is. Hi. I also am scarred by Johnson grass. And I heard you say that as you're following these plots that you go in and collect the seed heads off the Johnson grass. I was listening for what other kinds of techniques you might do to help increase the success rate for the native plants to grow. I think just even the seed heads off the Johnson grass isn't enough because of the roots, and I'm curious what else?
It's like, given that this is a research project, first off, shout out again to the forestry team because we're all out there cutting Johnson grass seed heads. So we're given that it's a research project, and again, we don't want to introduce too many management methods because we're really trying to see, what the effect of these methods are. We've wanted to, but we've avoided it outside of just going in and cutting off the Johnson grass seed heads, and we bag those naturally. We don't leave them out in the field. And then we also went out at some point and cut out some thistle as well because that started taking over in our plots. Which coming from, the side where I'm the person running the stats, I'm already like, let's not cut too much, guys. I don't know how to incorporate that into the stats. But yeah. And we want to, we just are afraid to, skew this too far as an extension project. Yeah.
We were wondering what kind of till you used to do it in the depths of it, as well as what you used for cover crop, if it was like a multi-species mix or...
The fall cover crop, or the cover crop, I believe, was winter wheat and 5 to 6 inch till.
Oh, right here.
Given the objective is to help the native pollinators, that's a lot of herbicide spraying. Have you tried just bush hog down every February and then let all the native come back? And you get the most amazing wildflower forage and the most amazing pollinators. Has anybody just tried that? Don't herbicide anything. Bush hog, 3 or 4 years, you get amazing forage. There is some invasives in there, certainly, but there's a lot of other natives as well.
So the goal of this project is really to answer the landowner question of how do I establish pollinator habitat? And then that would be a further question is how great is this pollinator habitat for native bees? That would be a different question. I'm sure there are people out there who do, the bush hog method, and I'm not certain what the success rate of that would be in this particular setting. Because this is a old hay field, it's full of basically 90% clover. I don't and it's mowed very frequently for hay. I don't foresee there being really anything else being able to pop up in this area. But yeah, the goal of this project is really just to answer those landowner questions. Yeah.
I'm going to further that also the comment and maybe address just supporting also management such as infrequent mowing, which is predominantly used to, get some of the material out of the way but keep the woodies under control. But yeah, that is a very valuable management strategy when you're not wanting to do a clean install 100%. And so you'd be looking at mowing frequencies of not greater than every couple of years. And so the reason that we did this project is years of many of us seeing failures, right? And the number one reason for failures of these kinds of installs, period, is poor competition control. So the worse your weed management is, the higher risk you're throwing all your expensive seed away. I'm sorry, what was that? Right. The comment was that if your other method is not through like a seed-based install, 100%, extremely valuable, and that's what many lands lean on is that kind of practice. This one in particular was, though, just to reiterate it, it was based on putting better data in the literature. One, to maybe we can support some better NRCS practices, right? Something like that, maybe more frequent sprays, but to reduce the number of failures with the seed install specifically. Yeah. So, yeah, anyway, next.
Winter wheat, right, as the cover crop. We used to do that too, and then Roundstone told us that it's like allelopathic, and it actually is like preventing the natives from coming up. So I don't know if that's another thing that you could add to your project, but that might be not helping.
You just reminded me, like yesterday, I was reading a paper, and this might not be the time or place to mention this, but regardless, we used the 2% glyphosate plus the 1% 2,4-D. I was reading this paper yesterday that basically said that, and that's a very common thing that people do is partner the two together to use them to target, pretty much anything you might be spraying. This was saying in particular, in the case of Johnson grass, it might not suppress the growth, it might actually antagonize the growth. And that's something I didn't know prior either. And I was like, oh, that's interesting. So yeah.
Yeah, that
So
was
we're definitely
exactly
learning
the
some
same
things
thought.
along the way as well about, what would be the best way of doing this.
I guess I have a two-part question. Are you doing any management between the years here? Are you burning down the field? Are you leaving them untouched? And then going into year 2, are you managing the diversification of the seed mix? One of the problems I've had is that first year, it looks great. And then years afterwards, it becomes very dominant by 1 or 2 species.
It's something we have discussed, and I think it's going to end up maybe being a bit of a wait and see because this is also a new project for us to be doing as well. But yeah, it's something we've discussed, but we're not 100% sure yet if we're going to have to or need to. And I think Jody's going to answer your question better than I can.
Yeah, so we will be throughout the time of establishment, because as Kristin had mentioned earlier, establishment is with a diverse seed mix is a multi-year process. We don't expect to see everything or almost everything till year 3, third year after seed install. But we are going to be talking about winter mowing. And at a minimum, what we're doing, which she had mentioned before, is things like foxtail and Johnson grass seed head management. That is very important, even outside of like an experiment, is to reduce your seed bank, because that is going to, within a season, you can have enough Johnson grass on any of these projects that you have shot yourself in the foot because you let that seed bank develop too extensively, and it's just extremely, extremely rapid. So a combination of mowing and seed bank management is our main strategy for that. We are limited to it being an experiment, but we're trying to make it as close to realistic as possible. So I hope that helps.
Have y'all done any work or thinking about doing any work on stale seed bread prep, essentially taking a silage tarp, putting it on the ground, letting the seed bank kind of work its magic, the plants come up, they don't get air, they don't get light, they die, and over a course of a few rounds of that, it really cleans the weeds out, then you can go in and then seed pollinator habitat. Have y'all done any work around that?
We haven't done any work, and you got something, Jody? Sorry. Yeah, it would be something, that we would explore next. We definitely we're very interested in, moving this towards exploring organic methods, since that is, an issue for certified organic people, but that might be, a route that we take in the future. Are you offering up land, David, to do this one? Yeah? Okay.
David, your hat circumference is so great. Anywhere you stand long enough, invasives cannot grow.
Yeah, go stand out in my plots this summer for me, please.
I was curious, obviously there's these tensions coming up in our discussion because it's a research experiment, right? And so you're trying to make it as relevant as possible, but you're really trying to isolate your variables. But when we were talking about the using mowing or these other methods, you mentioned that this was all hayfield before. Mm-hmm. So I'm curious if you were in practice and you were consulting or advising on pollinator development, how much do you think you would take into account what the land, like the state of the land at the moment versus wanting to blank slate it? Would you consider, what would be the main factors you'd consider about the landscape you're working with before deciding the approach?
the invasive species composition, not just, invasive species presence, but like what invasive species. Because like things like foxtail, crabgrass, those are going to be a little bit easier to manage. But if you've got, the fescue and the Johnson grass and bluegrass, it's going to be a lot harder to manage. And then, yeah, really it's just going to be a debate at that point of like, how much effort do you really want to put into it? Yeah.
Right here with Russ.
I've got a question kind of following up from the last one. Sometimes we're working with folks who have no agricultural or natural areas management training. It's not their job, but they're asking for, they want a beautiful wildflower meadow. You've got 3 weeks, go. And so they just don't have they know what they want, but they don't have a concept of what it takes to get there. It would be really helpful to see more, I think from more on the agricultural end, I think there's some good guidelines. I think the work that you're doing is doing great. And I think even some of the seed producers have good information. But I'm not seeing kind of standards getting into some of the municipalities or their organizations who are paying or funding for these things. But I think there's a little bit of a lack there or a lag. I think that the knowledge is out there with the practitioners, but the people who are setting up designs or bids and contracts don't even really know what to ask for. So my question being, like, do you see some of the information that you're producing now? What's the pipeline for getting that out? I can imagine you're doing extension publications, but could you be producing anything that other like municipalities or other institutions could use in terms of contract specifications or bid specs?
Gotcha. Hopefully this can go that direction. Like you said, we're definitely going to have some extension publications come out of this, at least one, research paper come out of this. And then hopefully, especially considering we've partnered with Roundstone on this, my goal is to really just have a guide. My goal in this position broadly is to be able to create, some sort of decision tree of like, this is what you got, what you've got to work with, and how do we get to where you want to go. So they're abstract goals at the moment, but yeah, hopefully that we can get that pipeline developed in some way.
Might have time for 1 or 2 more questions if anybody has any. We all good? All right. Thank you so much, Kristin.